limitless three-dimensional extent in which objects and events have relative position and direction. Space is not called boundless with no reason. The universe expands at an extremely fast rate, approximately 73 kilometers per second per megaparsec. Long ago, there were no street lamps, electric lights, just glowing wood fires. Ancient humans had time to look up at the moon, planets, stars, and other twinkling specks in the night sky. Legends grew about gods and spirits in a mysterious dark world far above. From 1610, the telescope made these tiny specks bigger. Astronomists realized that they were faraway worlds moving through a vast empty area called space. Space race of the Cold War was a trial of strength between the two world superpowers, the USA and the USSR. In this space race, the USSR scored 3 great achievements: an orbiting satellite, an orbiting human, and an orbiting space station. The USA followed a long-term goal and developed the most powerful rocket ever, the Saturn V. It sent the first humans to another world when Apollo 11 landed on the moon in 1969. Nowadays, space probes travel much further. They visit all the planets going around the sun, many of their moons, and small objects such as asteroids and comets. Much nearer and more practical for our day-to-day lives are hundreds of satellites orbiting the Earth. Space exploration technology can be divided into 4 main categories, namely vehicles such as spacecrafts or satellites, orbital launch vehicles, deep space communication technology, and in-space propulsion technology. Outer space colonization is expected to widen our horizons of the future of mankind by ensuring survival in case of a planetary disaster. Additional resources could also be mined from space to potentially expand the capabilities of humans and benefit society. SpaceX has been a dominant leader in this push for efficient exploration with the release of the Falcon 9, a reusable rocket. NASA's Artemis program aims to land another man and the first woman on the moon by 2024 and eventually establish sustainable space travel by 2023. Commercial Crew Development is a human space flight development program that will result in astronauts flying to the International Space Station on privately operated crew vehicles. As humans, we always want to explore the distant cosmos. However, our current technology is limited, but scientists have provided 3 main theories in which we can theoretically travel long distances: Einstein-Rosen bridges, warp technology, and hyperdrive. Einstein-Rosen bridges, also known as wormholes, is perhaps the most commonly known and the most likely to actually exist. Albert Einstein's theory of relativity predicted wormholes, although we haven't actually seen one yet. An Einstein-Rosen bridge, to put it as simply as possible, is a shortcut through space caused by the warping of space-time. Massive objects like stars or black holes bend time and space like a bowling ball on a trampoline. A massive enough object could bend space-time to create a connection between two otherwise distant points. The entrance to a wormhole has often been represented as a tube, but in 3D space it is thought to look like a sphere. Wormholes are an attractive approach to faster than light technology because they don't require you to break the speed of light. Physics tells us that nothing can go faster than light. With wormholes, shortcuts basically, spacecrafts could enter and exit at sub-light speeds. Warp technology is another way of possible space travel, as in the Star Trek series. The technology skirts around the impossibility of accelerating a ship past the speed of light. Instead, a warp drive bends space itself. It compresses space in front of the craft and expands it behind. The Enterprise is basically riding a bubble of regular 3D space while the universe changes around it. In 1994, theoretical physicist Miguel Alcubierre proposed a means of faster than light space travel, consistent with general relativity, inspired by Star Trek. Alcubierre described an engine creating an energy field with lower density than the vacuum of space. By contracting space ahead of the ship and expanding it behind, a spacecraft could ride a wave forward. Unfortunately, Alcubierre's proposal raises the same theoretical problems as wormhole travel. Just as wormholes would require massive amounts of energy and some as yet unknown material to sustain it, so would warp drives. Star Trek provided that energy with a make-up element called dilithium in crystal form. It is supposedly able to contain enormous explosive reactions of matter and antimatter. If we want our own warp drive, we are going to need a similar exotic energy process unknown to current science. Hyperdrive as a method of space travel has no theoretical basis like Einstein-Rosen bridges or warp drives. It may merely be another name for light speed travel. The idea appears throughout science fiction, though different authors use different names to describe the same concept. All of this narrative convenience leaves the actual mode of entering and exiting a hyperstate a mystery, one that is further outside the realm of possibility than wormholes or warp engines. Mysteries have been solved throughout the history of mankind. Somewhere, something incredible is waiting to be revealed. We feel that the mysterious secrets of space will come to light sooner than expected.